Today our lesson focuses on finding the vertex when the quadratic function is in standard form. Now if you recall, standard form is a, which is some number times x squared plus some number b times x plus c at some number c. Now when we talk about finding the vertex today, it's going to be a little bit different because we have a different format for how the equation is written. So our vertex today is going to be found in the form of taking the opposite of b all and dividing it by 2 times our a value, and then we'll substitute that value into the original equation to solve for y. So if we take a look at our first example, we need to be able to determine the vertex, axis of symmetry, and y-intercept for each function. Step 1 is going to be dealing with finding that axis of symmetry, and we're going to use x equals the opposite of b over 2a. So we have x, and b here is 10, so it would be negative 10 divided by 2 times a, and there's no number in front, so that's 2 times 1. So we end up with negative 10 divided by 2, which means that x is equal to negative 5. So then step 2 is going to be to simplify it, just like we did, which means that our axis of symmetry is going to be x equals negative 5. Moving on to working with finding the vertex. Step 1 of finding that vertex, again, we had already set up opposite of b over 2a to equal x, so we know x equals 5. So then we're going to follow with solving for, after we follow with solving for x, and this all can be done in one step, we're going to then go ahead and substitute those values from step 2 back into the original equation. So we have y equals x squared, which we know x is negative 5. So negative 5 squared plus 10 times negative 5 plus 3. And then we can go ahead and simplify that. Negative 5 squared is 25. 10 times negative 5 is negative 50. And plus 3. 25 plus negative 50 is negative 25. Plus 3 gives us negative 22. So our final step is going to be to write that as an xy ordered pair, which means that my vertex in our case is going to be negative 5, negative 22. But finally, we need to go ahead and do the y-intercept, which our y-intercept, remember, substitute 0 in for x and solve for y. So if we go back up here to our equation, we'll use this one here, we have here 0, y equals 0 squared plus 10 times 0 plus 3, which is 0 plus 0 plus 3, so y equals 3. And therefore, when we do our final step of writing it as xy, our y-intercept is 0, 3. Moving on to the next example, I want you with the letter b, go ahead and try finding the vertex, the axis of symmetry, and the y-intercept on your own, and then hit play when you're done. Alright, so first thing we're going to do is we're going to find x equals the opposite of b over 2a, which in our case, b is negative 6, so we have 6 over 2 times negative 1, which is 6 divided by negative 2, which is negative 3. So therefore our axis of symmetry is x equals negative 3. We're going to put that back into the original equation, so we get y equals the opposite of negative 3 squared minus 6 times negative 3 minus 1. Negative 3 squared is 9, and then we'll take the opposite of it after that, so negative 9 minus 6 times negative 3 is negative 18, so this actually becomes plus 18 minus 1. And negative 9 plus 18 is positive 9 minus 1 is 8. So therefore, our vertex is going to be negative 3, 8. Finally, our y-intercept, y equals the opposite of 0 squared minus 6 times 0 minus 1. 0 squared is 0, the opposite is that's still 0, minus 6 times 0, which is still 0, minus 1 is negative 1. So our y-intercept is going to be 0, negative 1. Moving on to example C. Example C, we do the opposite of b over 2a, we get negative 12 over 2 times negative 3. So here's b, here's a. Negative 12 divided by negative 6, which equals positive 2. So our axis of symmetry is x equals 2. Then going back and substituting that back in, we get y equals negative 3 times 2 squared plus 12 times 2 minus 8. 2 squared is 4 times negative 3 is negative 12. 12 times 2 is 24 minus 8. Negative 12 plus 24 is positive 12 minus 8 is 4, which means our vertex is 2, 4. And then finally, doing our y-intercept, we have y equals negative 3 times 0 squared plus 12 times 0 minus 8. Negative 3 times 0 squared is 0. Plus 12 times 0 is 0. Minus 8, that equals negative 8. So our y-intercept is going to be 0, negative 8. Moving on to our final example. We have y equals 1/2 x squared minus 2x plus 9. Doing the opposite of b over 2a. Opposite of b would be positive 2. And then we have 2 times a, which is 1/2. 2 times 1/2, half of 2 is 1. So you have 2 over 1, which is 2. So our axis of symmetry is x equals 2. Putting that back in to our equation, we get y equals 1/2 times 2 squared minus 2 times 2 plus 9. 2 squared is 4, half of 4 is 2. 2 times 2 is 4 plus 9. 2 minus 4 is negative 2 plus 9 is 7, making our vertex 2, 7. And then finally doing the y-intercept, you get y is equal to 1/2 times 0 squared minus 2 times 0 plus 9, which multiplying through and adding together, you get 9, which makes our y-intercept 0, 9. All you need to do is attempt the U-try problem and bring any questions with you to class tomorrow.